Hey, thanks for tuning in. Welcome to Nomadic Geek. In this tutorial, we'll show you how to set up a Node.js WebSocket server that listens to sensor data from different devices and streams it to any client connecting to it. We'll walk you through the process step by step and provide some tips and resources along the way to help you get the most out of your server. And as always, we welcome your questions and comments, so don't be shy. If you haven't seen the first part of this series of tutorials, WebSockets using an NV gas sensor, we suggest you watch it first if you're interested. As demonstrated in the video on your screen, we are exposing the sensor called electric gas to smoke in order to evaluate its response. As the smoke hits it, we can observe the values fluctuating rapidly. If you like this video, don't forget to give it a thumbs up and hit the subscribe button and notification bell so you know when I post more content. Stay tuned, and let's get started. We will utilize the AZNV module as an example to transmit sensor data to our Node.js server, although any other source would suffice. In order to gain a more thorough understanding of the procedure for sending data via WebSockets from ESP8266 powered boards, it is advisable to view the first video of this series. Open the Arduino IDE and open the project we created in the last video, if not opened already. Now we will uncomment the lines we previously commented out in the last video. It's time to see this functionality in action. Rather than simply observing the data in the serial monitor, we will now send it to a receiver that will manage the data for us. We will also have to change our network settings, or configuration rather. Go ahead and change the SSID constant to a string matching your Wi-Fi network name. This name is the one you see when connecting to it with any Wi-Fi device, such as smartphones. Then go ahead and change the password constant to a string matching your Wi-Fi password. The WebSocket server host is the IP to the computer that will be running our Node.js server. If that is a Windows machine, you can check that IP by going to the command prompt and running the ipconfig command, or if you are on Mac OS or Linux, you can check it by running the ifconfig command in the terminal. The WebSocket server port can remain unchanged. This port is used to differentiate between devices connected to the server, so for each device you are connecting to the Node.js WebSocket server, you must assign it an unused port. We will address this again when discussing the code running on our Node.js server. Ensure that you have selected the correct board, and then press Upload to transfer the binaries to the ESP8266 on the board module. Wait until you see dots appearing in the debug terminal. Then, press and hold the reset button on the board, then press and hold the flash button. Release the reset button, and immediately after, release the flash button as well. Once the upload is complete, press the reset button once more to allow the code on the ESP8266 to execute. Now, let's install what we need for the Node.js server. In order to build a Node.js WebSocket server, you will need an IDE and the Node.js runtime environment installed on your machine. While there are a variety of IDEs available, Visual Studio Code (VS Code) is a popular choice due to its extensive feature set and flexibility. To install VS Code, simply navigate to the official website in a web browser and select the appropriate version for your operating system. Once the download is complete, follow the prompts to complete the installation process. To download the Node.js runtime environment, go to the official Node.js website and download the version for your operating system. Once the download is complete, follow the prompts to complete the installation process. You can then verify that Node.js has been successfully installed by opening a command prompt and typing node-v. This should display the version number of Node.js that you have installed. Now, finally, we will take a look at the Node.js server. Now open a Windows PowerShell prompt by pressing the Windows key and then start type terminal. The best match will be shown. First, we are going to create a project directory, so go ahead and type mkdir followed by the name of the directory you want for the project. I am naming mine sockets. Now change the directory to the one you created by typing cd, short for change directory, followed by the name of the directory. I use the ls command here to list the files, but of course the directory is empty. npm, short for Node Package Manager, is the default package manager for the Node.js runtime environment. npm allows you to install and manage packages, libraries, that are published on the npm registry. npm init is a command used to create a package.json file for a Node.js project. The package.json file is a file that contains metadata about the project, such as the project's name, version, dependencies, and scripts. The package name will be the project's name, and I will call it Sockets Tutorial. The version number can be the default suggestion, 1.0.0. The description of the project will be "This is a socket tutorial." The entry point is the file that is run when the project is started. In this case, the entry point of the server is the server.js file, which is a JavaScript file that we will create soon. Test command will for now be the command we use to start and run the server.js code. For the time being, we can leave the Git repository and keywords blank. It is possible to modify the information entered in this setup at a later point in time. Author should be your own name. And license default. Project configuration is now done. Type yes to confirm. To open the contents of the directory, we can simply type code, which will launch Visual Studio Code from within the current working directory. The package.json file is the only file currently present in the project, and it was created during the npm init process. This file contains all of the settings for the project, which can be edited at any time. At the moment, we need to modify one of these settings, specifically, the script that is executed when the command npm run start is entered. Let's update this script so that it runs the server.js file instead. Now, we need to create the server.js file. To do this, we can simply right-click in the Project Explorer, located on the left side of the Visual Studio Code interface, and select the option to create a new file. Be sure to name the file server.js. We can start by adding the imports needed for this project. The first line is importing the path module, which provides utilities for working with file and directory paths. The second line is importing the Express module. It simplifies the process of creating and maintaining web servers and routes. The third line is importing the WebSocket module. We create an instance of Express middleware function that will serve static files from the public directory whenever a request is made to a URL that starts with /static, which we will make use of from the web client later on. This will keep track of the web clients connected to see the sensor data. Now we set up the sensor connections as JSON objects with settings. We set up a WebSocket connection for clients to connect to the server on port 8999. The server listens for client connections and adds them to a list for later sensor data streaming. We also establish a WebSocket connection for all sensors to connect to the server on the ports specified in the connections object. The code iterates through the list of sensors and sets a message listener for each one. Upon receiving a sensor message, we check if the data is an object. If it is not, we process it as a key-value string and split it into sensor object properties. Note that this is in preparation for a future video where we will be receiving a video stream from the ESP32CAM module. We also make sure to send the updated values to each connected web client. Then we set up a route for a GET request to the /client path and sends a file to the client as the response, and starts an HTTP server and listens for incoming requests on a specified port, 8000. We save the server.js file and reopen the terminal. We attempt to run the start script specified in the package.json file. We have not installed any of the libraries we are attempting to use. We can do so by typing npm install followed by the name of the module, in this case Express. After installing it, we try again. To install the VS library, we can instead add it to the package.json files dependencies section. This is more convenient than installing it individually. The Express library is already listed in dependencies. Save and reopen the terminal. Now, we can type npm install and hit enter to install all dependencies listed within the package.json file. We try running the server again and it starts listening on port 8999 for WebSocket connections from web clients. Ports 8887 and 8886 are for the two sensor modules, and the HTTP server listens on port 8000 as an entry point for web clients to initiate WebSocket communication. For the purpose of verifying its functionality, let us console log the data received from the sensors and observe the results. And there you have it. As we can see, the two sensors are successfully transmitting the desired data. In the next video, we will start building the web client's graphical user interface, GUI, and presenting the sensor data in a more visually appealing manner. The GUI will allow users to interact with and view the sensor data in a user-friendly way. Stay tuned. I'll see you again soon.